Alright, so in this lesson, we're going to cover 3 small projects which will help us go through a couple of forces and one specific function. So what we're going to do is we're going to cover, as I said, we're going to cover 3 things. Okay, so the first one, or not in any specific order, is this which allows you to have particles moving on a surface. Okay, now this is not a force, this is a function. Okay, so this function allows you to have any emission that you have to stick to a piece of geometry. Okay, so we're going to use it to see how we can generate particles to move, in a particular way. Okay, so this is first. Then the second is we're going to do something called as an axis force, which allows you to have particles kind of spin out in an orbit. Okay, so this is what we're going to look at. And then lastly, we're going to take a look at the curve force, which allows you to have, particles move along a particular curve. All right, so let's get started. So what we'll do is we'll start off with the curve force because that is probably the hardest to control. Okay, so what I'm going to do is I'm going to use the same curve. So what I have is I just drew this curve. So just a single continuous curve, and I drew something complex so that you get an idea of how you can control the curve force. So I resampled it so it has like a fair few points, and I did a group by range so that I could just select like the first point here, and I copied a sphere onto it. So that's my emitter, and let's just select all of this. So I'll do Control C and I'll come to a new file, and I'll just paste that. Okay, so this is what we have. All right, so the way it works is fairly simple. Just take a pop network and I'll connect this to the second input, the curve that we have, and I'll just jump in. And what I want to do is we'll just work with the constant activation. I'll keep it to, okay, let's keep it to 5,000 for now. And I'll keep it to $FF less than 100. And then I'm going to take the life down to around a life expectancy of 6 and a little bit of variation. Okay, now what you need to do is you need to look for curves. So you'll find 2 of them. There'll be something called gas curve force, which is for smoke. And then you have the pop curve force. So let's take the pop curve force and add it in. And then you just need to take in that particular curve. So that is the second context geometry. And there you go. Now, default, the radius is too huge because it keeps a radius of 2, but my curve is pretty small. So I'm going to just lower it down. Okay, the second is you'll need to sort of resample the guide spacing. Okay, so that it gives you, like, firstly, you'll need to resample the curve itself. So we can just come down to the shaping. Okay, and you have this option called resample curve, and we'll make it around 0.02. See, so that will give you a more smooth curve. And then I want to do the same thing with the guide spacing, so I'll make it 0.02. See, so there you go. So this shows you the actual, or 0.02. There we go. Okay. So you don't want to see this. I can just turn on show curve only. Like, you don't need to see the representation. You just want to see it for one specific reason, that this circle should be bigger than the emitter. Okay, otherwise, if it's too small, then the particles won't move along with it. So the influence radius has to be big enough so that it covers all the particles. So I'll just turn on show curve. And now if you press play, the first thing that happens is that, okay, it just sort of runs off in a crazy direction. So what you want to do is it does 3 things. It can do a follow, it can do a suction, which means it will sort of suck towards the center of the curve, and it can do an orbit, which will allow it to spin along, and then it can also inherit a velocity. Like if the curve has a velocity or something, it can inherit that. Which we can try and set up. So what I can do is I can come in here and I can take a wrangle, and we'll take an orientation along curve. So let's take an orientation. Okay, so which will set up our normals, and then we'll do at v is equal to at n. So if we come back into this and let's see if, yeah, it doesn't really, because the problem is it sort of runs off like crazy. Okay, so what you need to do is I'm going to make all of these 0. And you want to start with a value of around 0.05. Okay, like a very small value. And that will sort of make it move along, in that particular direction, but not really. So what is important is the air resistance. Okay, so the higher the air resistance is, the more it sticks to the velocity that has been generated. So let's jump this up to about 100 and see what we get. Okay, so now we're getting something slightly better. Okay, maybe we need to emit longer. So let's make it around 150. And let's get this to around 7. Okay, so it's still not enough. Let's try to get this to 0.2 and see what we get. Okay, yeah, that's a bad idea. So let's keep it to 0.1. Like the values have to be very specific. And then let's take the air resistance up to 1000. And let's play now, and there you go. So it has to be very specific, otherwise it doesn't work. Okay, now what I can do is I can try to sort of come in here to Vex expression, and it just says pass through, which means it will just show you all the all the parameters in here in Vex. And I'll just randomize this. So I'll do a multiply equal to, and I'll use a fit01, randomize the ID. So random ID, comma 0.5, comma 1. Let's see if that works. Yeah, so we get a little bit of randomization. Let's give it a little more life. Yeah, I think this is okay. So it's not like very straightforward. It's a little tricky, but it gives you the results that you want if you kind of know what you're doing. So the key is the air resistance. The higher your air resistance is, the faster it will move. Okay, and then you can try to play around with the other values. So we can try to improve the suction. And so what the suction does is it's sort of like, you can see it sort of squeezes in. And you can also try to do orbit. So we can try to increase the orbit. Again, the values have to be like really, really low. Okay, now we've broken it again. Like if it orbits too much, it doesn't move along the curve. Yeah, I think that's okay. So it's a nice thing to have when you want, particles to move in a specific way, but it's very tricky to sort of control it. And I can just try to increase the suction scale a little bit. Yeah, I think this is fine. And we can try the same thing. Like what I can do is I can just take all of this, do Control C, and we can randomize, all of it. Yeah, I think this is okay. Okay, now one more thing you can do is we can try to add a drag here. So I can take a pop drag and see if that gives me a little more control on everything. Yeah, I think this is nice. Okay, now one more thing we can do is rather than controlling the life, let's say I want the particles to die once they reach here, is I can do something called as a pop kill. So what pop kill does is it's sort of like a group thing, like it has similar values, but the one thing it has, so you can sort of kill particles based on an expression or something. But what I can do is I can come into bounding box. Okay, so I can take a bounding box and I can just move it to the side. Yeah, let me just move it here. And what this should do is once the particles sort of reach into that box, they'll just die. See? Yeah, and now I can lower the life again to 100. Yeah, this isn't bad. Or let's keep it to around 40. Let's do 50. Okay. Let me see. Let me get rid of the drag. Yeah, let's see if we can go faster. Yeah, the problem is the faster you go, the more it sort of, like, it tends to run away. Like, it has a habit of running away. Yeah, okay, I think this is good. If you see particles starting to run off, try to increase the air resistance again. So we'll make it around 3000. Yeah, they're still trying to run off. Okay, hold on. Let me. Okay, we can try something like those particles I want to get rid of. Okay, so what we'll do is, let's take another pop kill. And I can try to set up something by expression. So let's try kill by condition. No, let's do a speed. Okay, so we'll do length of at v is greater than 0.5. Let's see what that does. Okay, that's killing too much. Let's try greater than 2. Yeah, that's not bad. Okay, let's do, because we don't know how fast our particles are moving. Okay, so 5 is too much. So let's try 3. There you go. Yeah, 3 is good. See, so 3 kills everything that is too fast. Okay, and then just for fun, what I can do is I can try to add additional particles on top of this. So I can take a pop replicate and I'll keep it to around 15 particles, and the shape should be point, and I'll come to the attribute and make it minus 0.2, and yeah, I think this should be okay. So life expectancy of 0.5 with a little bit of randomization. Okay, let's drop this in and see what we get. Okay, so they're doing something, but they're going nuts. So let's do one thing first of all. Let's take this to 0.1. Let's get the lifespan down to 0.2. Okay, and then let's add a few more things to this. So we'll do a drag. So we'll take a pop drag, which will apply to the pop replicate. So it should be a little bit more under control. And then I'll take a pop force, which will also apply to the pop replicate, and give it a little bit of noise. Okay, let's try something. Let's take the pop replicate and let me make it 0. Yeah, okay. Don't remove the inherit attributes altogether. So it will give you like some additional, okay. Or let's try something. Let's take the velocity. Let's make it 0.02. So very slow. Yeah, there you go. Let's try minus. Okay, and let's also try to take the pop replicate, and we'll make around, let's try 5. Okay, so there you go. So you can do something a little more fancy with this. Okay, and then in order to color it, I'm just going to come back to my original file, because the coloring is fairly simple. Like, I just created the same stuff we've been making. So I have like a normalized age attribute and a speed attribute. So I'll just copy this. Okay, so I'll just do Control C and I'll come back here. So we'll come up to geometry level. I'll take a blast so I can separate out the replicated particle. So I'll do pop replicate, delete non-selected. Okay, and then do Control V. So, we have the age and everything added here. And then we can do a color. and set it to ramp from attribute. Let's pick up new age and we'll set it to two-tone. Yeah, there you go. So that looks nice. And then we can also take an alpha. So I'll take a point and I'll set it to alpha and we'll give it a ramp. So we'll do ch ramp and let's call it fade, and it'll pick up the new age as well. Yeah, there you go. So this looks nice. You can lower the intensity of the pop force so it doesn't really shake as much. But yeah, this is how you can use the pop curve force and have things move along a curve. Alright, so now let's take a look at the next one, which is the orbit. Okay, now I keep calling it orbit, but it's essentially it's called the pop axis force. It's pretty simple, but you can make some fancy stuff with it. So that's what we'll make. Okay, so let me just come back here. This is pretty straightforward. So I'm going to take a sphere. Okay, and let's just take a pop network. Nothing fancy to this. Okay, so just take a pop network and I'll increase the number of particles to around, let's try 25,000. Okay, 35,000. And I'll lower the lifespan to around, let's try 5, a little bit of variation. And then I'm going to turn off the guide. Yeah. Okay, and then look for pop axis force. So what it does is it gives you like two shapes. You can have a sphere or a torus, and it'll just, based on the size of it, right, it'll just move particles around in 3 different ways. Okay, so you can have an orbit. So the orbit just makes it spin and eventually it will move out like that. It can lift, so it can move upwards while it spins. So it's good for like a vortex or something. And then you can also have like a suction, which will sort of suck it in as it spins around. Or you can try to go negative as well. Okay, so this is kind of fine. So what we can do is, in order to create like the effect, and then you have fall offs of the whole thing. So what I can do for this is I can just lower the radius a little and get the height to affect just about that much. And if I press play, you'll just get like the middle part of it moving out. But what I can also do is I can come into the fall off and I can increase the outer strength so that you get a little bit of movement towards the outside as well. Yeah, there you go. So see, so that looks nice. Okay, now along with this, I can add like a force. So we'll take a pop force. Give it like a little bit of noise and let's press play. But let's do one thing. Okay, like I don't want the noise to apply to everything. So let's say if we want the noise to just apply to the fast moving particles. Okay, so I can take a pop group and there's a ready-made group function in there. Which is called fast particles. Okay, so we'll make it around 0.5 and I'll call it fast, and then this will affect fast. So what it should do is the majority center shape remains fine, but you can see the noise is only applying to the particles that are moving fast enough. Maybe I can lower this a little bit more. So let's try around 0.2. Yeah, so this is fine. So let's make a few changes to this to make it look a little better. I'll increase the life a little bit. Yeah, let me just lower the count for now, because I'll get it down to around 10,000 again. Yeah, I think this is fine. Okay, and let me just lower the noise. And let me just increase the spin a little bit more. Yeah, and then let's do one thing. Let's also give it a drag. Wow, that's a bit too much. Okay, and then let's just give it some color to make it look slightly better. But another thing we can do is, rather than have it emit from the surface, what if you wanted to emit from like inside? So what you can do is I can take a points from volume. Okay, so I can add a points from volume. I can give it a little bit of jitter and then come back into my pop network and I can make it emit from points. So you'll get, you know, something a little more interesting. See, so you'll get like these streams forming, which definitely looks a lot better. And I can try to, like, you know, let's lower the swirl and increase the, yeah, and then let's give it some coloring. Okay, so we'll take a pop color and let's do a ramp. Okay, there you go. See, so that starts to look nice. We'll flip it. And what I want to do is, let's say the center is like the sun. So it's sort of yellowish, but bright. So let's make it around 5. Yeah. And then like it's slightly maybe reddish. And let's get it to around 2. And then it changes into maybe like a blue or something. And then we'll also come into the alpha and we can set that to a ramp. Yeah, so there you go. See, so that looks kind of nice and fancy. See. And I can take the pop axis force and maybe I can adjust the height a little bit more. Okay, if it's sort of spinning out a little too much, okay, like let's say I wanted to spin a little faster, but when you do that, it kind of runs off. So what you can do is, you can sort of increase the suction speed. So what that does is kind of holds it in place. See, it will still spin out, but it won't sort of, you know, it won't run away. And then we can try to increase, you know, the amplitude of the noise so that it gives you, yeah, there you go. So that looks a little more, you know, interesting shape-wise. Okay, so this is as far as the basic, you know, pop axis force is concerned. Okay, so let's take a look at our final example, which is how to move particles on a surface. Okay, so what I'm going to do is we'll just take a test rubber toy, get rid of the shader, and I'll take a boolean and we'll do a boolean union. Okay, and then take a pop network. And now the basic is very, very simple. Let's try to take like a pop force. I'll give it some noise, so it's just sort of, you know, spinning out like that. I'll give it a drag to just, you know, control it a little bit. Okay, so this is fine. And I'll just lower the lifespan to around 3. So we have this. And now all you need to do is take a wrangle node and we want to stick it to this geometry. Okay, so you need to bring this geometry into the wrangle node. So what you have to do is you come into inputs and you say input is first context geometry. Okay, and then come into vex expression and the function is called minpos. So minpos, and it needs 2 things. It needs which is the input and what attribute are you picking. Like, it's very simple. So what we want to do is we want to modify the position of the particles. So we'll do @p is equal to minpos, and input is 0 because that's the first input. So it's 0, 1, 2 and 3. And then what you want is @p because we want the position of the new attribute or of the 0 input. And now if you press play, there you go. Like, it's literally that simple. Now what you can do here, which is a little more fancy, is let me just get rid of the. So what you can do is you can have like groups and then have a group transfer it to a min pos, like that's possible. So you got a lot of things that you can do, but on a very simple level, let's say if you want, let's say you want it to like be 50-50. Okay, like it's partially sticking and partially not sticking. You can do a simple mix. So what you can do is instead of min pos being in position, let's put it to a new vector. Okay, so we can just take a vector and let's call it new position. So this won't do anything, like this thing will just go back. Okay. And what I want to do is I want to take position to be a mix. So a mix is called a lerp, and it needs three things, right? It needs the two things that need to be mixed and the amount by which they need to be mixed. Okay, so we want to mix the current position with the new position by a value of 0.5, or we can do a ch and let's call it mix. Okay, and then just click that, so it will create the parameter for you. So if you press play right now, nothing happens. And then if I bring this to around say 0.5, you'll see like it's partially sticking and it's partially sort of moving out. Like if I lower it, see. So this gives you a little more like control if you want. And then if you want, you can mix it with age. So we can use the same sort of, the normalized age function and mix it that way. So that's also an option. So you can do a bunch of things. Okay, like what I can do is, let's say if I come in here and we'll create a new float value called, or let's just create like f at new age, and I can just copy it. Okay, so we have it somewhere. Yeah, we have it here. Okay, so I can just take this. So just do Control C. I'll come in here. Yeah, and Control V. And okay, now we'll also have to put the new age into a ramp. So let's do a float. Let's call it float. We can't use n, so let's call it lift. And we'll do ch ramp. This will be called lift, comma at new age. Click that. Okay, and then we remove the ch mix and we put in lift. So what we should get is over age, it will start to stick. Okay, so in the beginning, it's not sticking, or like, so this is what's happening, right? So when both of these are 1, see, it's sticking completely. And when both of these are 0, it's not sticking at all. So what we can do is, let's say it's supposed to not stick in the beginning and stick towards the end, okay, or vice versa, see. Okay, so what's happening is like it's sticking in the beginning, and then as the particles get old, they leave the surface. So it gives you something a little more fancy. Okay, now the question is, how do you, do the effect that I had done? So the simplest way is, first of all, get the pulse length to 0. So the noise remains static. Okay, like you'll get like fixed patterns, but it's still not like, visible enough to what we want. So what you need to do is, let's get this into input 2, and we'll just make a small change in the wrangle. Is input 1 will be second context geometry. And what we want to do with our emitter is we want to scatter some points, and we want to use those points for emission. So I'll come in here and let's do around 500 points. Come back into the pop network and use points for emission. And what this will do is, see, you get like, fixed values. And if I adjust if you adjust it a bit, see, so that gives you the movement that you want. And we can take, maybe like the swirl size can be slightly bigger, so you'll get like, larger volumes. and we can have it spin around a bit more. And you can try to increase the sub steps if you want. So we can take the sub steps to around 3. So we'll get more detailed, movement. Yeah, that's pretty much it. And then we can just take a pop color again over here and drop it in. And let's try to keep this to, this isn't bad actually. Yeah, let's keep this to like a blue or something. No, I think this looks nice. And we can probably give it like an alpha as well. No, it should be visible in the beginning and then fade out towards the end. Yeah. So see, so you get like these nice little patterns that it is forming. And then it's all based on how big or small your swirl size is. So if the swirl size is really small, you'll get more, smaller patterns. And then I can just mix it with my original geometry. So if I just do a merge, so if you want to see it over the actual geometry, I can just do that. Yeah, this doesn't have an alpha. So just take a point and give it an alpha. And also give it a color. Yeah, see, so you get like these nice little patterns, forming over it. Like I can take the point size to be slightly bigger. And then let's increase the number of points. So I can come into birth and make it around, say, 45,000. Yeah, see. And let's get the swirl to be bigger. Because the point here is like you have to make sure that your pulse length is 0. If the pulse length is higher, it'll look nice, but it'll keep moving like this. That doesn't look very good. It looks bad. Okay, so just make sure that your pulse length is 0, so the noise remains fixed. And that gives you like a better result. And if you don't like the noise type, you can always just offset it. So I can just come in here and then I can just offset the noise. So I'll get like a different pattern. Yeah, see, there you go. Oh, that looks much better. So if you don't like a particular noise pattern, just, offset the values and you can get a different noise pattern. All right, so this is pretty much it. So this is two forces and, a function. And what we'll do next is we'll start looking at how to set up volume velocities. Okay, because another way to sort of control particle movement is by generating volume velocities. So that's what we'll take a look at in the next video.